You're probably asking yourself why I am here in a laboratory with all these chemicals. It's a good question, but I've loved chemistry all my life, and today I'm happy to be able to share some of that love with you, and hopefully you'll be able to carry that over with the people you're teaching. So these kits contain a lot of really interesting stuff, and I'm going to show you now how we test for the metal components, the cations, as they call them, of compounds. So we've got a couple of compounds here. Some of them look very colorful and interesting, other ones don't. This purple color is cobalt chloride. That is sodium chloride, that's copper chloride, that's calcium chloride, and that is potassium chloride. So they're all the same anion, that's the chloride. They all have the same end to their compound, but they all have different beginnings. There's copper, cobalt, sodium, calcium, and potassium, and we're going to teach you now how to test for those. So what I've done is I got a stick. This is a very clever piece of apparatus which I engineered myself. You've got a little stick and a little piece of wire on it. The wire is not going to react with any of the experiments because it's the kind of wire that doesn't react with anything. So if you want to make one of these for yourself, it's the best way to test it, because then you can wet the wire in a little bit of this methyl alcohol so that the various salts will stick to it. You dip it into the salts, in this case cobalt. See, a little bit of it sticks to there. And then we put it in the open flame to see what color it burns. Look at that. Beautiful. That's cobalt. Do you see that color? Magic. So it'll allow us to, with any cobalt salt, be able to determine whether there's cobalt in it or not. So I'm going to do it again. And this time we're going to use sodium chloride, which is good old table salt. It's the stuff you use to make your food more salty. Not too much, they tell me. It's bad for your blood pressure. Here we go. Yellow. A nice, bright yellow flame. That's sodium. So we're already working out which elements, which metals are part of these salts just by burning them in the flame. The third one is this very beautiful color. It's copper. Copper chloride. Now, copper chloride is not a particularly interesting salt all on its own. Of course, you know the copper metal. You'll be able to guess what that looks like. But what color will it burn? Well, we'll see now. Isn't that beautiful? That sort of greenish blue that you saw earlier is the color of a copper salt in flame. And it gets interesting with potassium. You have to look very carefully at this. Potassium chloride, we burn that in there. It's a sort of a lilac color. It's kind of a violet, maybe even a light pink if you look carefully enough. So not as bright as the copper or the sodium, but still there. And then we can try calcium, although this one I think I'm going to have to pick up with the forceps because it comes in little flakes. Calcium chloride is not a powder like the others. So I'm going to hold that in the flame and we should get a color out of that too. Do you see that red? That brick red is the color of calcium. So now, if I mixed all of these up, you'd be able to tell which one was which. And you can obviously do these experiments fairly easily in the lab. There's not really a lot that you need except for the flame, the burner, and then obviously the salts themselves. But do put them on something like this so that you don't contaminate the contents of the actual bottles if you put them back in there. So if I take one just at random, don't look at it, and then I'll get you to guess which one it is. See if you can get it. Just for fun. See if you can guess which one this is. There we go. It's copper. Copper chloride. Ta-da! Isn't that cool? Metals are fascinating. They're the most interesting elements, I think, on the periodic table because you get so many different kinds of metal. Most of us think of steel when we think of metal. We might think of iron, which is an element. There are more metals on the periodic table than any other kind of element, and there's such a varied and very glamorous group of them. So I thought we'd look at some of them quickly. They're in your kit. We've got magnesium, zinc, lithium, iron, and copper. So we can start with the one that's probably going to disappoint us a little bit, which is copper. It's a beautiful metal. It's obviously the only red-colored metal on the periodic table and in the world, in existence, in any place. So it looks very pretty, but doesn't really do much when it burns, as you'll see. So I'm going to take our wire. There's some copper turnings on there. Let's see what happens to them. Not a lot. There's a slight color in the flame, sort of a yellowish, pinkish color, and the copper actually melted and has now fused with that wire, so that's an alloy. Anyway, copper doesn't react with very much, which is why we use it in pipes and for plumbing and that kind of thing. And it's an old metal. We've known about it for years, thousands of years, and humans have used it for any number of things, including cooking utensils and pots and things like that. Iron is also one of the elements that we've known for a long, long time. It's very abundant on Earth. It's an interesting metal because it can be made into so many different things. And iron has an interesting quality in that it burns in a way that might be familiar to anyone who's ever seen the inside of a foundry or anywhere where they work with metal. So look at iron when it burns. Watch what happens. There, some sparks. I'll actually do it this way just to demonstrate how it burns properly. There, did you see that? That's iron. Just creates lots and lots of little sparks. Cool, huh? And those are just filings of iron. The next one is zinc. Zinc is used to make rust-proof things, so we call it galvanization. You galvanize other things by adding zinc to them. So zinc is actually a little less reactive than most, but it's still more reactive than iron and copper. And when you burn zinc, it should burn with a certain color too. So let's try that. We'll try with the wire first. So you take a little bit of zinc. We made these filings with a hacksaw. So if you're having trouble getting your zinc from granules to filings, just get a hacksaw. And you can see not very much is happening there. There's some sparks. I want to try one other thing quickly because I think this wire has actually got so hot and there's so many metals on it now that it's probably some sort of superpower. Here's the zinc if you just drop it into the flame. So it sparks a little bit like iron, but it also burns with a relatively dull flame. Magnesium is a lot more exciting. I think you're going to like this a lot. So with magnesium, we can take the wire and we can try it on there first. These are just some very, very small powdery bits of magnesium. Look at how they burn. Isn't that cute? Beautiful. So magnesium really doesn't let you down. Magnesium is a very light metal, and I'll show you now if we use these how it can burn and what happens when it does. It burns at a very high temperature and produces a blinding white flame. So it's like looking at the sun. Take a look at this. And there she goes. Isn't that cool? And you can see that magnesium actually melts while it's burning. And there it is, and you're left with a string of white powder, which is magnesium oxide. All right, the last one, and the one that I'm a little bit nervous about, is lithium. Lithium doesn't really get along with water, and it's a very reactive element. You'll see that it's covered in oil, because it comes in a bottle where you have to store it in oil, because otherwise it will react with the air. And the reason I'm a little bit nervous about lithium is because all of those elements on that side under lithium, sodium, potassium, they're all very reactive. So they react with pretty much everything. So I just want to make sure this is nice and dry before we carry on, and then I'll show you what lithium does in the flame. So we'll take just a little piece of lithium here. By the way, this is the lightest solid on Earth. Lithium is so light that it even floats on top of oil. And obviously it'll melt almost immediately in the spoon. This is also part of your kit, and then you'll see what will happen. There we go, and there the lithium is burning. It's already formed an oxide. See sort of a reddish flame? That's the lithium burning. Goes a bit yellow there. And there we are. It's caught fire all on its own. So as I said, very reactive. And you don't really want to dip that in water now. It's hot and it's lithium. So we'll just put that over there safely. So those are just some of the metals and how they burn. And obviously by the flame color you can tell which metal is in something or which metal something is made of. And the smaller the pieces, the more well they burn.